In the open stage, the stomata opening has a certain amount of length to it because we puff it up, we open it out. Once we pull the water out of that and it deflates that stomata opening, it actually changes the size of it, so it gets longer in size. So think of this piece of paper as your corn leaf, and the stomata openings on the back side, most of them are back here, 10,000 areas, size of a dime. When they close, in a closed state, to stop the water from coming out, they're actually longer than they are in an open state. In essence, we're making the back side of this paper larger than the front side. As we make the back side larger than the front side, we cause it to roll, and you're causing the rolling of the leaf. So that's not wilting. Sometimes we think, oh, my plant's wilting. No, it's rolling. And the purpose of that is it's a God-made function to take the surface area away from the sun, to shut down the solar panels because things are getting too hot. It's a protection mechanism. So when we see our plant roll up and unroll, that becomes part of the potassium management of the water and temperature within the plant. So we can see that in a corn plant as it starts to roll. Now, potassium is a mobile nutrient, and it's the most highest concentration at the surface, so we should see the top leaves that do the most rolling and gradual all the way down. Now, if you don't have enough potassium in your plant, your top leaves will roll and the bottom leaves will wilt. And if they can't protect themselves from the sun, they can't roll up, then they'll start to scorch and burn. So it becomes, again, an important part of that function of managing that water in those critical, maybe 2 or 3 week period when we're running tight on water supply. Now, soybeans are somewhat similar, but instead of rolling, they tend to fold together. So you can see the back side of that leaf as the trifoliate closes down together. The harder we shut down both the corn and the bean plant, unfortunately, them are not very productive GDUs. So if we're rolled up from 8 in the morning to 3 in the afternoon, while yes, we got those GDUs, but we didn't produce much photosynthetic activity. And when we don't produce it, then we're going to cannibalize. This plant's going to go somewhere else where the food was already made and stored away for a rainy day or a hot day, and it's going to use that as energy. It's still going to burn energy off of this plant, but it's going to be food that was stored. And unfortunately, that food was stored for grain fill, and we're using it for growth in the growing season. Now, as we think about the deficiency symptoms out here, being mainly present in the sap, it's very mobile in the plant. So potassium can be moved from the stalk and the older leaves to new growth up on top. So we always look for deficiencies at the bottom. So as potassium is pulled out of those lower leaves, those cells lose their turgor pressure, and they're going to start to wilt and die off. It's going to look like somebody's burning the bottom of that plant to some extent. So when we look for potassium deficiencies, we can't see those 55 mile an hour going down the road. We're going to be out in the field, and we're going to be looking down low in the ground as far as the lower leaves that are down there. Potassium deficiencies will start at the tip of the leaf, and they'll work themselves down the outer edges. So that's different than let's say, a nitrogen deficiency. So it'll be burning from the tip of the leaf down the outer edges, and it'll be on the oldest leaves, the lowest leaves in the plant. Now, this is similar to saline toxicity, but that saline toxicity would be at the new leaves up at the top. Potassium deficiencies at the bottom. Again, different than nitrogen deficiency. Nitrogen deficiency is down the center of the midrib. Potash is down the outside. Both of them starting at the tip, both of them starting at the bottom end of that plant. Can you have them both at the same time? Sure you can, especially in a drought or dry conditions. Potassium is stored in the stalk, so we're taking in potassium at a high rate and we're storing it everywhere because it's part of moving water and nutrients up through the plant. When we get to the point where the plant can't bring potassium in fast enough to meet its daily needs, then it's going to go to storage. It's going to empty those cells. And when it empties those cells, they get a kind of a styrofoam appearance. We call it cotton pith. And it's going to start at the ear leaf and go up and down that stalk, meaning the stalk is its warehouse or reserve for that potash, and it's going to go back to start moving it around. So as we look at this stalk, we got vascular bundles in here, and in those stringy vascular bundles is your xylem and phloem tubes that are moving water and nutrients down. We're going to move coming up through the xylem and processed into food and sent back down through the phloem and sent to other growing points where we don't need it, it's stored. And in this case, we're storing potassium between those veins. So this area in here is storage for potassium that we can use, especially on those days when we can't pick up enough potassium due to water shortages and the plant rolling. Now, once we pull the potassium out of those storage cells, and nitrogen's in there as well, so we're pulling them both out. We pull them both out, then they take on the cotton pith. So they have a pithy styrofoam appearance, and that's kind of like a dipstick. So we can split that plant and we can start at the ear and look down that plant. How deep is that cotton pith and how fast is it moving? As we say, we want a good solid 2 nodes at the bottom when we're coming into pollination, and we want at least 1 good node down there when we're coming into black layer. But if we have cotton pith to the base of the plant and we hardly have pollinated yet, then it's an indicator we're probably going to have standability problems. We're not going to be able to build the turgor pressure that we need when we need it to support this plant.